And without further ado, I will bring up my slides. Oh no, it cut out on me. 2 seconds, be patient. Thank you for waiting, appreciate it. Here we go. JS1, all right. I'll boot these up. And now we're rolling, now we're going. All right. All right, let's make this a lot bigger for all of you. What is programming? Programming, whoa, what is it? Okay. What is programming? Ooh, why did it do that? Yeah, let's try this one more time. Sorry, y'all. Thank you for bearing with me. I'm using a monitor for the first time in a while, so there's a little bit of a difference in my setup, but not to worry, not to worry. Let's just do it this way. All right. Let's do it this way. Dang it. One more time. We'll try this out. Okay, let's go to, you know what? That's what we'll do. Oh boy. Starting out real hot here. Okay, what is programming? Programming, like we kind of talked about in the first lesson, programming is just a way of thinking about how to build something, and it's thinking about how you're going to build it. It's coming up with a recipe or a list of instructions for a computer or something to execute without you, and to keep on executing it until you tell it to stop. So programming, once again, is concerned with transforming input into output. That means just I'm going to give my program a certain set of things, maybe a certain set of information, and then it is going to create something. It is going to have some sort of output, some sort of result that it is going to transform that information into. That is going to transform that information into. Yeah, that's proper to say. It involves logical analysis and decision making. Once again, that just is, it involves you thinking about how you're going to solve it. Maybe like we talked about, maybe you were like in a baking recipe analogy. I think we talked about that the first class. If you put it in that way, like maybe baking for 20 people is different than baking for 2 people, right? And the way that you would accomplish those 2 different tasks would require you thinking, making considerations about how you're going to bake, how you're going to change your recipe to meet those needs. It involves completing tasks at scale, which goes along with this analogy, right? Like trying to consider how you can write code, or how you can make your solution the most efficient, so that it can handle those 20,000 baking cake requests. It's a social activity. It usually involves talking it through with another developer. You know, I don't know if you guys do this, but when I'm just in my own zone, I make assumptions, or I follow a certain thought pattern based on my isolated brain. But when I code, or when I program with someone else, they can point out different ways of doing things, or maybe where my assumptions are faulty. So having other people engage in programming with you is a really, really beneficial thing. And finally, it's a creative process. Ultimately, you're creating things. You're you're creating tools or things that people can use to have fun or accomplish something. So it's very creative. The pattern that developers follow when they're programming is to code something, to write code, and then to test it to see if it works, right? Does it work as I expected it to? Most of the time, that's going to be a no. And then after that, you do what's called debugging. You try to figure out, okay, what went wrong? What did I code, and how can I improve it? And it's a cycle. You know, it really never stops. You once you code something, you test it out to see if it works, and then you edit it. You go back and you try to improve it. So when we're coding, to me, like one of the best ways that I can start to write code is by doing this thing called pseudocode, which is just to write out, like in plain English or plain language, I should say, what is the best way to do this? What do I need to do? It's like writing a to-do list. You know, it's kind of like when you have a big job to do, one of the best ways that you can organize yourself, get your thoughts straight, is to write down, okay, the first thing I need to do is this, then this, and breaking it up into chunks, and making that to-do list detailed enough to where it gives you a sense of what you have to actually go out and do. So this is what we're this is a really great tool and what we're talking about with pseudocode. So when creating,
Question.
yeah, sure.
To writing technical business requirements.
Yeah, so technical business requirements, that's a really great question. Just to clarify, if anybody doesn't know, technical business requirements are sort of like expectations for how a project should perform specifically and what it should actually do. I think that pseudocode is a little bit more directed towards implementation. It's directed towards what the code is actually going to do, whereas technical business requirements are concerned mostly with output, right? Most of the business requirements that I get will say something like, my program will calculate 2 plus 2, right? Or calculate numbers based on a given output, and it will render it in this way. Whereas pseudocode will be like, okay, I get numbers, I apply first number to second number, right? It's not code. It's not like specific, like actual implementation stuff. It's just sort of like a high level, this is what I need to do to reach those requirements, to fulfill those expectations. Did that answer your question?
Yes, it did. Thank you.
Okay, cool. So in creating programs, before learning the syntax and the concepts of a programming language, it's important to figure out like the purpose of a program. What is the program supposed to do? And how will the program be structured? So sort of like building out our to-do list. What do we need to do? What's the end goal? And what are all the steps that we need to execute in order for that to happen? So we got a couple of examples here that, like, I need a program that is going to text me before work if there's a chance of rain, right? So I could approach this and say, okay, so what does this thing need to do? It needs to text me, and it needs to text me in the morning, and it needs to text me whether or not there's a chance of rain. So I need to write a program that will, at like 7 o'clock in the morning, it will figure out if whether or not it's going to rain today, and then it needs to text me. right? Like that's kind of what we're getting into with the pseudocode. I'm not talking about like going out and setting up some sort of like text bot or like something that's actually going to be able to do the texting. I'm not talking about like setting some sort of like alarm clock. I'm really just stating like a to-do list. Okay, like it needs to first figure out this, then it needs to do this, and then it needs to do this. And as a developer, I can go in with that kind of structure and I can just focus on one thing at a time. Okay, first thing I need to do is figure out this alarm clock situation, this doing something at a certain period of the day. Second example is I'm not in close touch with my family. I want to create a program that sends an automatic email to each of my family members Wednesday at 8 p.m. asking like how their week is going. So I would come in here and I would say, okay, so I need some way, figure out a way of triggering an email, triggering something, triggering my code at 8 p.m. every Wednesday. I need to go through, I need to have a list of my family members and go through each of my family members. So at 8 p.m., go through a list of my family members, send them an email, right? And we can break down like more detailed things to do from there. But this is the purpose of pseudocode. What is pseudocode? Pseudocode is an informal set of instructions that describe how a program operates in simple language. It is used by many programmers in the early development stages of a new program. Let's take a look at another example. So we've got a robot here. I built a robot. Whoa, I'm really smart. That robot is named Rusty, and Rusty is going to make me coffee, right? So when I tell Rusty to make coffee, Rusty is going to make a fresh pot of hot coffee. So pseudocode things that I would do is I would say, okay, Rusty, go into kitchen, open up cabinet, locate coffee maker, pick up coffee maker, put coffee maker on counter, plug in coffee maker to outlet, turn on coffee maker, right? Like, I guess this example really shows you that computers are dumb. Computers are really, you have to be verbose with them. You have to, like, every tiny little step, you have to tell Rusty what to do. But by doing this, it makes it easier to figure out like all of the, it prevents you from forgetting anything or leaving out any steps. So locate coffee maker in the kitchen, fill the coffee pot with water using the nearby sink, pour the water from the coffee pot into the coffee maker, locate the coffee filter in the kitchen, place the coffee filter in the coffee maker, find the coffee grinds in the nearby blue container, measure coffee grinds to make a full pot of coffee, place coffee grinds into the coffee maker, place coffee pot, right? Here's a second example of a program we need to make where this robot's going to go around and clean up each of these 4 squares. And so the pseudocode might be clean the current square this robot's in, look around at possible moves we can make to other squares. If one of those moves leads to a dirty area, move to that area, go back to step 1. So if it moves to that area, goes back to step 1, it'll go clean current square, look for possible moves, figure out if we can move towards a dirty area, move towards that area. If there's more than one option, pick one at random. And then if there's no dirty area to move in, that means we're done. So here it'll say, okay, clean our current square, look around for dirt squares. Okay, we found 2. There's 2 options. Pick one at random. We move to that square. We go back to step 1. Clean the current square, look for possible moves, move to that square, clean it, look for a square, move there, clean it, look for any possible moves, any dirty squares. There are none. That means we're done. So like this, this section, the whole like, what is programming? It's hard to speak on, I think, because it's a practice, right? Like if someone was like, what is music? You'd be like, well, let's see. Music is a collection of notes, and it's a practice. It's really just boils down to like thinking of trying to figure out a list of instructions to tell the computer to do, and then constantly thinking about like how we can set up those instructions so that they can support or support different changes that we might make in the future, or maybe like consider efficiency. Yeah, and pseudocode is like the tip of the iceberg of like how you can start to think about programming and how you can begin to think about how to solve a problem without just sitting down and coding it out. Yeah. Okay, cool. Any questions about what is programming?
No.
All right.
I have a question.
Yeah, sure.
What is the difference between programming and coding? Because I feel like we're kind of using it interchangeably.
Yeah.
I'm not sure.
Very good question. So programming is like, they are different. Coding is like the actual writing of the code, whereas programming is like involves like design and like thinking about it before you do it. I really want to come up with a good analogy. It's like I want to say like writing, like maybe like writing a paper or like creative writing might be, you could say like it's scribbling. So there's a difference between writing and like scribbling, right? Scribbling is like the actual physical writing on a piece of paper or something, whereas like writing has to do with like planning out what you're going to write or like researching things.
So programming is kind of like the outline, and code is the actual paper that you write.
Yeah, I think that's
something like that.
I think that's an like a very good way of putting it.
But
Yeah.
you need to program always before you code.
Yes. Yeah. Very good.
Thank you.
Yeah, of course. Man, admittedly, this is like one of the hardest sections for me, because I'm like, it's very like philosophical. Kamal asked, is programming meaning the like making the code work? Yeah, as well. It's changing the code physically so that it will work.
Is programming like building an app, basically? You can build an app through coding?
Yeah, programming is like actually writing the code that is going to make it work, whereas programming, wait, what did I just say? Programming is like designing, creating the whole app, planning it out, and coding, whereas coding is just like typing away. Cool. Any other questions?
You know, it kind of reminds me of instructional design, because that's what my degree is in. And it's about the pseudo code that you were talking about. It's writing those steps out for you're writing instructions. So somebody that knows it well might skip a step, but you've got to be as simple as get the pencil, get the checkbook, get the calculator, you know, that type of stuff. And then you go into the designing piece. After you've structured it with that, then you go designing, and then the actual making the e-learning is sort of like the coding.
Yeah, I think that's a really good example as well. All right, thanks y'all. Thanks for helping clarify. I appreciate it. Cool. Let's learn about some JavaScript. JavaScript is awesome. JavaScript's one of my favorite things in the world. Once again, it's the brain. Ooh, look at this little animation. All right, what we're about to learn is the different kinds of data that JavaScript can manipulate, how to store this data for use for later, and how to make decisions based on certain conditions, how to organize code and data into meaningful units. So the different kinds of things that we can play with in JavaScript and the different types of things that we can move around, how to store those things so that we can pull them out later, how to make different decisions, how to make different things happen in code based on certain conditions, and then how to organize your code as well as maybe that data into meaningful chunks. So JavaScript, the history of JavaScript was created by a guy named Brendan Eich for Netscape in the 90s. And it was included in an early version of Netscape in 1995. It was basically developed as a way to have a programming language that can run on your browser. Browsers were like a really big new type of program in the 90s. And with browsers, they have to pull HTML and pull code in from a source and run them right there on your browser. And so there's a certain amount of flexibility that has to happen. It's not like what's called a desktop application. It's not like you put in a CD and you install it on your computer and then now you can run it on your computer. You're fetching it from a server or some website. You're pulling it off the internet. So the way that it had to run was a little different. What is ECMAScript? ECMAScript is the standardized scripting language that forms the basis of JavaScript under the organization ECMA International. It's just like the standard set, hey, this is the official JavaScript stuff. So that ECMAScript is like the organization that runs the official JavaScript language. JavaScript is super popular. It's basically if you're on a web, it's if you go to the web and you are filling out a form, you're using JavaScript. JavaScript is everywhere nowadays. JavaScript can run what's called client side, server side, and in the database, client side is when you pull up your browser and you hit a website, a bunch of stuff goes onto your computer. It's the stuff you see when you pull up a website. All that stuff is client side. It's on your computer. There's also somewhere out there a computer called a server, and a server will take requests from your computer, from your browser, and it will say, oh, you want this, and it'll give you information. It'll give you data. That's a server. And so JavaScript can also now run on a server. And then a database is like a big storage computer that just holds information, just holds data. And we can structure that data with JavaScript now. So JavaScript, unlike any other language really, can run in all of these different sections of an application. Why JavaScript? The future of web development has moved towards what's called single page applications. That's to say that about even 15 years ago, the way that you would interact with a web page, right, is you would go to the home page and then you'd click on a link and it would take you to like the shopping page. And then you go to another page. But now if you go to something like Spotify or Facebook, you don't change pace, you don't change pages. You stay on one page, and based on what you click, different elements, different HTML elements come in and move out, and you stay on one page the whole time. That's what's called a single page application. And JavaScript is essential to make that happen. So JavaScript is here to stay. Apps such as Gmail, Asana, Trello, Facebook, Google Maps. It's great for beginners because you can use it across the full stack. So like I said, all of those different sections, client side, server side, database, you can use one language to write an entire web application, which is really cool, as opposed to having to learn this thing and having to learn this thing. The languages that we're going to learn in this class, like that's it. That in order to just make a web application, a really sophisticated one, those are the only 3 languages that you need. So it's pretty cool. All right. Any questions on like all of that? I feel like I've been like saying a lot of really like, I don't know, really sophisticated information. Happy to like unpack any of it.
It's me again, Shamanda.
Hey,
sorry.
No worries. Happy to
Okay.
answer questions. Yeah.
How often is there new programming languages created, or how often do they become obsolete?
It depends on the language. So like JavaScript was developed 1995. So it was developed, is that 25 years? Oh my gosh. 25 years ago. That's like ancient history in tech. That's crazy. Languages are developed, I would say, like probably every 5 or 6 years, a new language will develop or like be derived from another language. They say like, oh, language A, we really like this thing and this thing and this thing about it. What we're going to do is we're going to change it enough to where it's a different thing and it'll capitalize on those 3 things, but try to solve for X, Y, and Z, which we don't like. But Java, so it depends, you know?
Yeah.
JavaScript though has sort of stood the test of time. So it's pretty cool.
Yeah, that's what made me ask when I saw 1995. I said, oh, wow.
Yeah.
That's pretty old.
Yeah, it's pretty old. And it hasn't changed that much. They've come out with like improvements to it. The latest was 2015, which is even crazy to think about. That was like the last changes were 5 years ago, and people have been using those. The other thing you have to think about, though, especially with like programming languages and even JavaScript, is that like if a company, even like Facebook, right? Facebook's 15 years old. That's a pretty old company in a lot of ways. And if they were going to choose a different language by this time to like write all their code in, they've got 15 years of like work that they would have to go back in and write. So it's a give and take thing. Like a lot of new companies will like take the newest, freshest languages and put them all in. But older, like bigger companies will oftentimes have like the classics. They'll just have the hits. Yeah, awesome question.
What is the resource for keeping up on the new like changes that comes out for a language?
Oh boy. Well, I mean, like,
Wouldn't you think GitHub would be a good one?
GitHub would be a good one. I use I follow this news site called Y Combinator. Let me like actually get the spelling for that. And I'll post it real quick. But it's like any kind of news site. GitHub is a big one, but that's sort of like a big collection of people doing things and making projects. I don't know how great the like receiving information is, or like keeping track of it. It's a good like library to search for, but I don't know how good it is as far as like I want to update on this new thing. But yeah, hype. Hype's the biggest one. You know, like if there are going to be new changes on a really big system, then like, or on a big language, like you'll hear the hype about it coming down the track and word of mouth.
So how do you decide what you stay up with? Because I think like I took JavaScript with Oracle, and it was Alice. And of course that was, Alice jumped on the rabbit and she wasn't supposed to. That was but there's so many different languages that come out and so many new things, you know, that you just don't know which ones you should learn or not learn. You can't learn them all. And I know JavaScript is pretty, you know, straight across the board. It's used a lot. So how do you decide between what you learn and what you don't learn?
Yeah, for sure. That's like the big question.
I know.
It's a really big question because there's a thing called analysis paralysis that's definitely real. I experience that all the time. It's like, oh, I need to learn things to get better, but like here's a library of 10,000 resources that I could use or not. I would say that it boils down to two things. Like one is if you have a job or like have any kind of like maybe you're in school, or maybe you have like a path towards a specific type of development, then whatever is inside of that like domain. So like my first job out of school, I was looking around at this thing called .NET. Like I kept going on job boards, and a bunch of people wanted .NET. So I was like, I better learn this. And then now my job wants me to learn this thing called Ruby. So
Ruby,
Ruby, which is cool. I mean, like if you are like in a business, like you'll kind of get whiffs of like, oh, okay, it seems like I need to learn this, or it seems like, or like my job wants me to learn this. Outside of that, like honestly, it's just what you care about. For a long time, I didn't care about any of that stuff. I wanted to make applications. I wanted to make applications easily and be able to like, I didn't want to get have the language get in the way. So I just used JavaScript, and I would try to get like really deep into what the language did and get a deep understanding of how it worked. So there's a lot of ways to care. Let's see. I got two questions. One from Justin. I think it's going to be more to turn. Oh, right. Yep. Good question, Justin. How easy is it to move from one programming language to another? So JavaScript, the example Kamal uses here is JavaScript to Java. Those are two completely different languages. It just depends on the language. With each language, they're trying to solve different things. Sometimes they'll have like completely different ideals around the way that they do it. So it depends on that. Going from something like Java to .NET wasn't that hard. They kind of try to do similar things. So it's all dependent on that. Another question was, how do you handle just older versions of HTML and CSS? If I have to update an older app is a really good question. So at my last job, I did have to update an older app, and the best way to do it is with gradual changes, you know, figuring out how you can just change one section like maybe 1 or 2 web pages, so that the user doesn't come in and experience a really drastic change in the experience. And also, like, trying to rewrite an entire code base is really hard. So sometimes it's just like a matter of writing something new and throwing out what you had before. You also have to get a bunch of OKs from your managers who are like trying to get, they don't want to spend, typically managers don't want to spend a long time updating or like doing changes of things that don't have a direct business need. So like there's a whole bunch of different considerations for it, but yeah, to directly answer your question, it's like gradual, doing some research, figuring out if there's like a mid ground to where I can say, okay, I'll update it to this point where I know that like I don't have to get rid of everything. I can like capitalize off of these things. So there are these things called compilers or transpilers rather, that will take new code, like take new features and translate it into old language. So those are really useful as well. Yeah, really good questions, guys. This is really good.
There was a couple apps that like they all have like similar layouts.
Mm-hmm.
Is that like just because they like obviously there's more than one way to write it to make it look similar, or are they just like copying and pasting and trading layouts?
You're talking about how they like look, right?
Right, and function a little bit too.
Man. Yeah, cool. Yeah, so they're not copying, but that is by design. There is a certain school of thought that when you like a shopping website, right? Like a shopping website.
Yeah, that's exactly what I'm thinking about.
Yeah, there's like if I model a shopping website off of Amazon, then there is going to be a certain contract, like a certain expectation for you going in and seeing, oh, this looks like Amazon. So like I use Amazon all the time. I know where this thing is. I know where this thing is. It's getting past the point of you having to figure out what the website does and where everything lives, and getting you to buy stuff, like getting you to be able to use it. Like that's kind of the impetus behind that is like, how can we get the customer, or how can we get the user past the point of like thinking about things about like using the website and actually using it. So and also like a lot of times there's no reason to reinvent the wheel. Like Amazon's built really well. Like it's built, like they have really rich people that work for them that that design everything. The reason they're rich is because they're really good at their jobs, So like, I'll just follow their lead, Like the problem is not design is not a problem of how can I make this look good? It's a problem of how can I get someone from point A to point B, Justin had a question of how frequently do the bigger corporations, Google, Facebook, hire people from all over to work remotely? Well, I mean, now, like now that's a little different. I don't think I know really before the current situation. I know that like Apple had like a lot of really weird requirements for living in San Francisco and the Bay Area. Google and Facebook, I think, have offices all over, but it's a cultural, like it's company culture to company culture. So it depends. Good question. Awesome. Any other questions before we jump into tonight's lesson about JavaScript? Okay. All right. Let's do it. Let's get into some JavaScript. Man, awesome questions, you all. I really enjoy having the discussions with you. So data types. Data is information, right? Like the number 2 is a piece of data. So we're going to talk about all of the different types of data that JavaScript can use. Data is stored in variables. Variables are like boxes that you can store data in and then reference it later. So like 50 is a number, right? Num of states, if we wanted to like hold the value of 50 and just like, instead of having to write 50, 50, 50, 50 over and over and over again, if we wanted to be like something that will always point to it, we could just write num of states and then store 50 into it. Same thing like name, right? We want a word, a collection of character, a collection of letters.
Can you click on it so I can see it?
Yeah, sure.
In the corner is kind of small.
Click on, hold on, let me get this out of the way. What exactly would you like me to click on?
I'm trying to see what you're talking about.
Oh, okay. What exactly was the screen in the way there? All right, let's see. Sharing screen.
It wasn't
okay, there it is.
Is that better?
Yes, thank you.
Okay, cool, great. So, sorry, num of states, you can see 50, name, George, answer, false, right? So we're taking values, we're taking data, and we're storing it inside of these things called variables. And we can use these variables, we can name them something that will have some kind of like meaning, right? Num of states, 50. Okay, there's 50 states. So now I can kind of assign a meaning to this number. George, name. Okay, someone's name is George. Answer, false. Okay, so there's a thing, there's an idea or a piece of data that is false, and now I'm going to store it in a variable called answer. Values are data types that have like a specific purpose and intrinsic behavior. So a number, a word, like a true or false value, they have like an intrinsic type of behavior. A variable is an identifier or a label for a value. A couple of rules: it can't contain spaces. It must begin with a letter, an underscore, or a $sign. Can only contain numbers, underscores, letters, or $signs, and it's case sensitive. Capital N num of states is a different variable than lowercase num of states. And it can't be what's called a reserve keyword. So you see that var, V-A-R there? That's a reserved keyword. So you can't have var, right? Like the computer won't like that. And they can be created with either let or var keywords. Take your choice. At this point, for this class, it'll just be like whichever one you prefer. You might prefer var because it sounds like variable. So here are the primitive data types, the basic data types. There's a string. A string is like a collection of letters. So they're analogous to words. The way that we write them is by putting quotes on either side of them. You have numbers. You have Booleans, which are just either true or false. So that can either be one or the other, true or false. Undefined means that like this variable, this value doesn't exist. It hasn't been given a definition. And then null is no value specifically. So like I could say 0 or like an empty string or something like that, but both of those still like are values. Like 0 is still a thing, right? It's still like a value, but null specifically means this has no value. This has been given no value at all. Then we have some complex data types. And just for reference, like you won't have to know all of these at once. Some of these we are outside of the scope of this class, but like we'll go through each of these sort of one by one. You have objects, which they can store multiple values. They store them in what are called key value pairs. It's similar to like a dictionary. Like a dictionary has a bunch of words. And if you go to a word in a dictionary, you'll find a definition, right? So it's like that word is a key and the definition is a value. That's similar to how an object works. You have arrays. Arrays are ordered lists. So here we have a piece of like, I don't know, an array that is 1, 2, 3. So the fact that they're in a specific order matters. You have dates, which just like are, I don't know, they're like the computer's system, like clock system. You can get like date and times, things like that. Regular expressions, which are like ways to match, ways to sort of like match values. We will not have to worry about regular expressions in this class. And then functions. Functions do stuff. Functions are kind of like recipes. They're kind of like recipes that you can snap your fingers and it'll just start making the thing. Functions are kind of like verbs. We'll go over that like in actual detail too, but this is really just like a preview of all of these. So a number. Numbers are used to perform arithmetic operations, right? So like addition, subtraction, multiplication, division. We can say, okay, we can do 5 plus 5. We can subtract, multiply, divide. Like numbers can perform these operations. Then we have strings, which are a series of characters enclosed by an apostrophe or a quotation mark. So it's a series of letters or maybe symbols that are enclosed by question marks or apostrophes. Typically, they're used for like words or sentences. So in this case, we have a variable full stack, and the value stored in that variable is the string full stack. We have a variable academy, and the value stored in that variable is space academy, right? Like there's a little space in there. You can see because like the quotation, there's a little gap and then academy, where the other one doesn't. So that's what I mean by like symbols. You can include things like spaces, or hyphens, slashes. And strings can perform this thing called concatenation, which combines or adds or smushes strings together. So in this case, if we say full stack plus academy, we'll take the value of full stack, right, which is that string full stack, and we'll take the value of academy, which is that string space academy, and we'll combine them into a new string full stack space academy. So that's what concatenation does. It smushes them together.
If there was no space in the academy up at the top, would there be no space in the combined one?
Correct. It would go, it would be one word. It would be like one big word. Gotcha. Good question. On strings, we can also run this thing called dot length, where we can get the number of characters in that string, including 0 for an empty string. So if we want to know the number of letters inside of full stack, we can do, and notice that that's the variable. We can do full stack dot length, and we'll get back 9 for 9 characters. We have Booleans, a binary data type with 2 possible values. So this is just a way of saying like Booleans can only be one of 2 values, true or false. A Boolean is always only either true or false. Oop, let me go back to that. True or false. Then we have null and undefined. Undefined has not been given a value yet. And null has no value, specifically has no value. These aren't important completely for now, like the differences, but be careful not to confuse the two. One has not been given a value at all yet. And then the other one has been given a value, and that value is no value. Arrays. Array is a value that stores multiple values in a particular order, right? Similar to a list of values. Each value stored in an array is separated by a comma. Oops, sorry, getting happy fingers. Then we have objects. Objects use a combination of properties and values known as key value pairs to store the data. So here down at the bottom, we have an object, and the key is cattywampus. And then the value is this string askew awry, right? So like if I look up, if inside of this object under the key cattywampus, the value I'll get back is askew awry. An object is similar, like I said, to a dictionary entry where the property represents the word, like the word that you go and look up, and then the value would represent its definition. You can think of objects as like a group of keys. So once you have the key, you'll be able to access its associated value. And then finally, we have functions. A function is a reusable chunk of code, and it's similar to a recipe. It has a list of lines that you can execute one by one. And when you call it, when you invoke it, when you tell it to go, it will execute all of those lines that you defined one by one. So an example for like a cooking recipe, we have this function called bake cookies. So the first thing it does is it defines this variable flavoring, which is equal to some flavor that I give it, some flavor that I pass in through this function and say, hey, use this flavor. So I could pass in peanut butter, I could pass in chocolate, I could pass in caramel. Then the next thing we do is define this variable batter, and that is equal to the value of flavoring, which we just defined right up above this, and then servings, which I'm going to pass in. I'm going to pass that value into this function when I call it. Then the next thing we do is preheat the oven. We call another function here. We call some function that we've defined somewhere else to preheat the oven, and then add the cookies to the baking sheet. So here on the right that just popped up, these are my function calls. The big chunk up at the top is called my function definition. It's where I define what the function is going to do. And then the function call is where I point to the function and I say, okay, function, do the stuff I told you to do with these values passed in. So for flavor, use chocolate. For servings, use 5. Then below it, I can call it again and say, okay, function, go. And use vanilla for flavor and use 10 for servings. And comments in JavaScript, we can write 2 ways. One is just like a single line. You can do // and you can comment on one single line, or you can, similar to CSS, you can do /** and you can write multiple lines and then close it with */. And there we go. That is JavaScript.